Dear students, we'll discuss some of the problems in atomic structure, then stoichiometry, followed by gaseous state. Example 1. So a photon having a wavelength of 310 nanometer used to break the bond of A2 molecule having bond energy 288 kilojoules per mole. The percentage of energy of the photon converted into kinetic energy is. So here 1 EV is given as 96 kilojoules per mole. Now what they're asking is the photon is used to break the bond. So 310 nanometer is the wavelength and the bond energy is 288 kilojoules per mole. This photon is used to break the bond and the remaining energy of the photon is transferred as kinetic energy. So we have to find out what is the excess energy of the photon remaining which is converted to kinetic energy. So we'll go through the solution. So bond energy is given as 288 kilojoules per mole. So we know that 1 EV is given as 96 kilojoules per mole. Therefore, bond energy becomes equal to 288 by 96, which is going to be 3 EV. So for each bond, the energy required to break that each bond is 3 electron volts. Now on the other hand, we have lambda as 310 nanometers. So if we find out the energy of that is equal to Hc by lambda. So if we substitute, this is 6.625 10 to the power minus 34 into 3 into 10 power 8 whole divided by lambda will be 310 into 10 power minus 9. So if you simplify this, so 6.625 into 3 Hc value is going to be 1.98 into 10 power minus 25. If we divide this as 310, I'll write as 3.1 into 10 power minus 7. I'll convert this joules into electron volts, 1.602 10 power minus 19. If you simplify this, so it is 1.98 divided by 3.1 into 1.6 into, so this is 25 minus 7, which is going to be 18. This is 19. So 8 minus 18 the numerator, minus 19 denominator, it becomes 10. So 10 into 1.98 is 20. So this is around 5, approximately you get 4 electron volts. So the energy of the bond is 3 electron volts and energy of the photon is 4 electron volts. Therefore, excess energy is 1 EV. Therefore, percentage converted to kinetic energy is equal to 1 by 4 into 100, which comes to 25%. So the answer would be option A. So we see the same thing in the solution also. It's going to be option A. We'll go to the next question. Which of the following transition will have wavelength different than that of observed in the rest of the transition? So out of 4, one of them should give different wavelength or wave number, the other 3 should give the same. So you have to verify for all 4, then we can identify which one is giving a different wavelength. We'll go to solution. So first one, hydrogen atoms transition 3 to 1. So if I write the formula for wave number is R into Z square is 1, 1 by N1 square, N1 is 1 and N2 is 3. So 1 by 1 minus 1 by 9. So this will become 8 by 9 into R. So wavelength will be 9R by 8. So wave number, wavelength, whatever want we can verify for all four. So this is for A. So B, we have helium plus ions, and fifth excited state means N is equal to 6 to first excited state means N is equal to 2. So helium Z will be 2. So nu bar is equal to R into 2 squared whole into, so N1 is 2, N2 is 6. So 1 by 2 squared minus 1 by 6 squared. So this will be 4R into 1 by 4 minus 1 by 36. If I take 4 common, 1 by 4 common, 4R into 1 by 4 becomes 1 by 1 minus 9. 4 get cancelled. This also become 8 by 9 R. So A and B gives the same value of wavelength. We'll go to the third one, C. C is what? Lithium 2 plus ions and 9 to 3. So lithium 2 plus ion, 9 to 3. Lithium is Z is 3. So nu bar equals R into 9 into 9 to 3. So 1 by 3 squared minus 1 by 9 square. So 9R is equal to 1 by 9 minus 1 by 81. Again I take 1 by 9 outside. This will also come out to be R into 1 minus 1 by 9, which is nothing but 8 by 9 R. So all three are giving same. So fourth one should be the answer, but still we'll verify that also. So the fourth one is beryllium 3 plus ion, 12th to 3. 11th excited state is 12 and N is equal to 3. Beryllium Z will be 4, hydrogen, helium, lithium and beryllium. So we'll verify that. Nu bar equals R into 16, 12 and 3, right? 12 and 3, yeah. So 1 by 3 squared minus 1 by 12 squared. This comes to 16R, 1 by 9 minus 1 by 144. So if you take this, this becomes 9, 16 times is 144, 15 by 144 into 16R. So 16R into 15 by 144. This will be 9 times. So this is 15 by 9R. So it is going to be D as the answer. A, B, C gives the same value of wavelength or wave number. D is giving different. So answer should be D. Let us move to the third question. So it's a big question, just carefully go through this. A hydrogen-like species with atomic number Z has the electron in a higher energy level N. The electron can make a transition to the first excited state, that is N is equal to 2, by emitting 2 photons continuously with energy 2.64 eV and 48.36 eV. So that means the total energy difference between the second level and the higher level is sum of these two values. The electron can also make a transition to the third excited state. From the same higher level, it can come to third excited state means N is equal to 4 by emitting 3 photons successively 2.64, 2.66 and 4.9. So sum of these three will be equal to energy difference between the fourth level and the higher level. So we have to first find out what is that higher level corresponds to, then we have to find out the atomic mass number Z. Sorry, atomic number Z. Okay, so we'll go through the solution. So first one is total energy is 2.64 plus 48.36. So this comes to 51 eV. So the level coming is first excited state, so En to E2. So what is delta E? So delta E is 51. So delta E equals 13.6 into Z square into 1 by N1, that is second level, so it is 4 minus 1 by N square. So delta E is 51 is equal to 13.6 into Z square 1 by 4 minus 1 by N square. So this is equation 1. The second one is N is coming to third excited state, so N is equal to 4, and this time the sum energy is 2.64 and 2.66 and 4.9. So 2.64 plus 2.66 plus 4.9, this comes to 10.2. So what I can write is same way, 10.2 is equal to 13.6 into Z square into 1 by 16, that is fourth level, and 1 by N square. I have two equations now. You can divide one by the other. So 51 by 10.2. 51 by 10.2. 13.6 Z square would get cancelled. So in numerator I have 1 by 4 minus 1 by N squared whole divided by 1 by 16 minus 1 by N square. So this is 10.2, 51 is 5 times. So it cross multiply 5 into 1 by 16 minus 1 by N squared is equal to 1 by 4 minus 1 by N square. So if you rearrange this becomes 5 by 16 minus 5 by N squared is equal to same 1 by 4 minus 1 by N square. If you rearrange this, 5 by N square goes to the right, 1 by 4 come to the left. So 5 by 16 minus 1 by 4 is equal to 5 by N squared minus 1 by N square. So terms containing N square I took together. So if you simplify this, 16 and 4, that is 1 by 16 is equal to 5 minus 1, 4 by N square. So from this I can write N squared is equal to 16 into 4, or N is equal to 4 into 2, which is equal to 8. So higher energy state is 8th level. So once I get N as 8, substitute in one of the equation. If I go back to the first one, so 51, this one if I take, so 51 equals 13.6 into Z square. So 1 by 4 minus now 1 by 64. So if you simplify this, 51, 13.6 into Z square, this will be 64, and 4 is, this is 15, 16 minus 1. So it comes to 13.6 into Z square into 15 by 64. So Z square is equal to, cross multiply, 51 into 64 divided by 13.6 into 15. If you carefully simplify this number, it becomes 16. So Z is equal to 4. If Z is equal to 4, the element should be hydrogen is 1, helium is 2, lithium is 3, beryllium is 4. Yeah. So Z is 4 is for beryllium. Answer should be C. think answer given wrong. Barium, boron is 5. It should be C. Z is 4. Example 4 is based on the wave function. So, wave function of 3s and 3p orbitals are given below. So, the expression is so big, the expression makes scarier, looks scarier. So, the problem is actually not that difficult. So, psi 3s is given 1 by 9 root 3 4 pi sum z by a naught 6 minus 6 sigma minus sigma square. Then sigma is nothing but 2 zr by NA naught. These are the expressions given. You have to select the correct statements among the following. So, it is basically with respect to the appearance of nodes, angular node or radial node. So, you have to find out first what is the value of R value for formation of node. That means we have to square this and equate it to 0. So, in all the problems of wave function, generally you have to approach with psi squared taking to be equal to 0. The constant terms are the full terms like this, they will not become 0. The term involved here will become 0. So, first equation I will take. So, 1 by 9 root 3 cannot be 0. So, and square of 1 by 4 pi square root, that 1 by 4 pi is not 0. Z by a naught to the power 3 by 2 to the power square will not be 0. So, only this term in the bracket will be 0. So, if I solve that, 6 minus 6 sigma minus sigma squared equals 0. One second, I think it should be plus, I believe. So, sigma squared, this should be plus. So, sigma squared minus sigma 6 equals 0. Then if you solve this quadratic equation, sigma will be equal to 5 or sigma will be equal to 1. And second one, if I take 4 minus sigma will be equal to 0. That means sigma is equal to 4. So, I can see the sigma value is not coinciding for these orbitals 3s and 3p. So, if you go through the question again, so a naught is Bohr radius, or if you solve for r, sigma is 2 zr by Na naught. So, sigma is 2 zr by Na naught. Substitute that first one, phi equals 2 zr by Na naught. From this I can write r is equal to 5 Na naught by 2z. This is the distance at which the radial node is formed, and if I say sigma equals to 1, then 1 is equal to 2 zr by Na naught. So, r is equal to Na naught by 2z. That is the distance at which another radial node is formed in case of 3s orbital. And 3p orbital is given here, and also you have one term containing cos theta. So, sigma is equal to 4. If you substitute, what do we get? So, sigma equals 4 equals 2 zr by Na naught, 2's are cancels. So, r is equal to 2 Na naught by z. So, these are the values at which radial nodes are formed for 3s and 3p. And the option says one more with respect to the angular node. Angular node depends upon the angle theta. So, cos theta is becoming 0 when theta is equal to pi by 2. So, cos pi by 2 is 0. So, square of that will be 0. So, at theta is equal to pi by 2, angular node is found at 3p orbital. So, if I go through the options now, total number of nodal surface is same for both 3s and 3p orbitals. So, in general, total number of nodes includes both radial node as well as angular node. It is equal to n minus 1. So, n is 3 for both 3s and 3p. So, n minus 1 is 2. So, both of the orbitals will have 2 nodes. So they may have different radial and angular node, but total number of nodes will be same for any orbital in third shell. So 3s, 3p as well as 3d. The angular node surface of 3p is at theta is equal to pi by 2, which is also correct. Then the third option, the radial nodal surface. The radial nodal surface of 3s and 3p are at equal distances from the nucleus, which is wrong, because as we solved here, so the values of sigma is not coinciding. The value of r is different for all the three nodal points. So the radial node surface for 3s and 3p will not be at equal distances from the nucleus. This is a wrong statement. So A is right, B is right, and 3s electrons have greater penetrating power than 3p electrons. As a penetrating power, s orbitals are much closer to the nucleus. S electron penetrates towards the nucleus than 3p, which is a correct statement. So answer should be A, B and D. A, B and D. So I think the solution is clear. I'll go back to the solution once again. So just equate the terms in the bracket to 0, find the value of sigma, and that will be the distance at which radial nodes are formed, and by this you can answer this question. Example 5, the radial probability distribution curve of an orbital of an atom has 4 local maxima. So radial probability distribution curve that has 4 local maxima, and also the orbital has 3 angular nodes. Which orbital we are talking about? So option 7f, 8f, 7d and 8d are given. So if I go through the radial probability distribution curve, so if you draw the graph, so it has 4 local maxima, means one start with like this, 1, 2, 3 and the fourth one is a bigger one. So this is the maximum probability. So 4 maxima are there, means there are 3 radial nodes. So there are 3 radial nodes. And also it is given that there are 3 angular nodes. So total nodes will be 6. So the n value should be equal to 7. So n is 7, so whether it is 7d or 7f. So if I take 3 angular nodes is given by the value of L. So L is 0, it is S, L is 1, then it is P, L is 2, D and L is 3, it should be F. So L is 3 angular nodes, so it should be F orbital, so answer should be 7F. So answer A. Example 6, the de Broglie wavelength of a neutron at 300 Kelvin is lambda, and the de Broglie wavelength of neutron at 1200 Kelvin is being asked. So one concept you need to remember here, the de Broglie wavelength is affected by temperature. The thermal de Broglie wavelength is given by an expression lambda is equal to h by root of 2m k and t, where k is the Boltzmann constant. So if I take two different temperatures, 2m k will remain constant, h also constant, so I can write lambda 1 by lambda 2 is root of T2 by T1. If I take lambda 300 as lambda and lambda 1200, that is being as, because at 300 Kelvin it is lambda. So square root of 1200 by 300, which is equal to root 4, which is equal to 2. So lambda 1200 is equal to lambda by 2. So as the temperature increases, since it is inversely proportional to temperature, the de Broglie wavelength decreases. So this is one important relation you can remember. So lambda is equal to h by root of 2m kT, where T is the absolute temperature, K is Boltzmann constant. So answer is C, that is lambda by 2. Example 7, it's a matrix match type. So you can see option A, electron moving in second orbit of helium plus. So second orbit of helium plus means what? So n is equal to 2 and z also equal to 2. So if n is 2, z is 2, then if you see the options in the right hand side, radius is 0.529 angstroms. Radius depends upon n by n squared by z. So this is the Bohr's first orbit value. If the radius to be equal to 0.529, then n squared should be equal to z. Here n is equal to z, so n squared not equal to z. So A is not possible. Total energy is 13.6 eV into 9, means z will be 3 and n should be 1. So that is also not applicable. If I go further, velocity of the electron is 2.18 10 power 6 by 3 meter per second, and de Broglie wavelength, if you solve for de Broglie wavelength of first orbit of hydrogen atom, it will come to same thing. So because it is same as n and z both are same, so the value is similar to n squared by z. So energy will be same as, kinetic energy will be same as the first orbit of hydrogen. So option S will be matching for A. Then second one, electrons moving in third orbit of hydrogen atom. So electron is moving in third orbit of hydrogen atom. N is equal to 3 and Z is equal to 1. If Z is equal to 1, N is equal to 3, total energy of the electron will be minus 13.6 into Z squared by N square. So Z is 1, N is 3, so we cannot match for A or B. So if I go further, velocity of the electron, velocity is proportional to Z by N. So Z is 1 and N is 3. So 2.18 10 power 6 meter per second is the velocity of electron in the first Bohr orbit. In the third Bohr orbit, it has to be 1 by 3 times of that. So B will be matching for R. A will be matching for S. Third one, electron moving in the first orbit of Li2 plus. If I take electron moving Li plus Li2 plus, N is equal to 1 and Z is equal to lithium. So it is going to be 3. So Z is equal to 3, energy will be Z squared by N squared into 13.6 with a negative sign. So N is 1, Z is going to 9, 9 into 13.6 eV. So it means it's going to be Q. So Q is matched for C. An electron moving in second orbit of beryllium 3 plus. So beryllium Z is equal to 4. If I take beryllium 3 plus, Z is equal to 4, N is equal to 2. So I can see very clearly N squared is equal to Z. So if N squared is equal to Z, radius depends upon N squared by Z. So both get cancelled out. It becomes equal to radius of first Bohr orbit, that is 0.529 angstroms. So the final matching would be A to S, B to R, C to Q, and D to P. So the answer should be S, Q, R, P. So we'll see the solution. S, Q, R, P. That is the answer for this particular matrix match. We'll go to the next question. Integer type, the simple one, the de Broglie wavelength of electrons in two orbits in the two orbits is in the ratio 3:5. The ratio of their kinetic energy in these orbits are. So if I take kinetic energy expression, de Broglie wavelength, so lambda is equal to h by root of 2m e. So if I take two different orbits, so lambda 1 by lambda 2 is equal to h and 2 and m will be same, root of e2 by e1. So lambda 1 by lambda 2 is given as 3 by 5 is equal to root of e2 by e1, that we have to find out. If you square it, 9 by 25 equals e2 by e1. So if it is e1 is to e2 is nothing but 25 is to 9. So if I take the value, kinetic energy of electron in these orbitals will be, so 25 by 9, you have to convert into numerical value. So 9 2s are 18, 7 70, 9 7 the 63, 7 again 2.77 would be the answer. So numerical type, it can be asked in the examination. Simple one. So the lambda value is equal to h by root of 2me. So lambda 1 by lambda 2 is e2 by e1. Square it and get the ratio between e1 and e2. So we'll go to the next question, example 9, which is a comprehension. So carefully read the passage given. The radiations emitted by atoms of an element in the excited state consist of a definite wavelength. These radiations give characteristic line in the emission spectrum. But when the atom is placed in external magnetic field, the spectral line will split into 2l plus 1 values corresponding to the value of magnetic quantum number, and this phenomena is known as Zeeman effect. So splitting of spectral line in presence of external magnetic field is called as Zeeman effect. Further, if I go further, the spectral line due to transition from L is equal to 1 to L is equal to 0 in presence of external magnetic field. What happens, because L can take -1 plus 1 and 0, m value for L is equal to 1 will be -1 plus 1 and 0. Three lines are going to be obtained because of three possible values of m. The theory of Zeeman splitting shows that the transition are allowed only if the change in magnetic quantum number is either 0 or plus or minus 1. This is what is given in the passage. So carefully read through the passage. I will give you 1 or 2 minutes time. Read the passage. Okay, so we'll go to the first question. The selection rule for allowed transition in Zeeman splitting. So we just now saw the transition is allowed if the magnetic quantum number changes from either 0 or plus or minus 1. So it cannot be any of these three, it has to be only this. So it can be plus 1, it can be minus 1, it can be even 0. Simple straightforward question. Selection rule will come in spectroscopy. So this is actually spectrum. So selection rule for the transition, allowed transition and forbidden transition will be there. So allowed rule is delta m is equal to 0 or delta m is equal to plus or minus 1. Based on this, we have to find out which transition is allowed, which transition is not allowed. So selection rule will be this one. So option D is the answer. So next question, which of the following transition is not allowed in Zeeman splitting? Which is not allowed. So if I take the values, so from L is equal to 2 to L is equal to 1, delta L is not going to matter. So M is plus 2, M is plus 1. So difference here delta M is going to be plus 1. So it is allowed. M is minus 2 to 0. M is minus 2 to 0. So delta M becomes minus 2, which is not allowed. M is 0, M is 0. So delta M is not changing, 0 it is allowed. And M is minus 2 to M is 0. So delta M is again minus 2, 0 it is repeated. So it is going to be 2, it is not allowed again. So answer should be B and C, both are same option. So I would say both can be the right answers. So we have to see the selection rule, what is applicable for the Zeeman transition. It should be either 0 or plus or minus 1. So answer should be D along with B also. B is also repeated here. Question 10, which of the following statement is correct? So if you take the radial part of the wave function depends only on the principal quantum number, angular part of wave function is independent of principal quantum number, then psi squared gives probability of finding electron at a point in space, and radial probability distribution function gives a probability of electron being present at a distance r from the nucleus. So out of these four, if you see, it's completely conceptual. So radial part of the wave function is the r. So how it is going to vary with respect to r? Different radial nodes are going to be there. Radial nodes were different for 3p, 3s, 3d. So it depends not only on the principal quantum number, and also it depends upon azimuthal quantum number, because radial nodes are going to depend upon different orbitals. So 3s it is different, 3p it is different, 3d is different, 4d, 4f it is going to be different. As in the same main shell, if the orbitals are having different number of nodes, the radial function definitely depends upon value of L also. So the first one is incorrect. Angular part of the wave function, angular nodes is dependent only on the azimuthal quantum number. It is thus not depending upon principal quantum number. Angular part of the wave function is independent of principal quantum number, which is a correct statement. Number 3, psi squared. All of you know psi squared is defining the probability density, and this probability density is going to be at a point in 3D space around the nucleus. So even this is also correct. And radial probability distribution function, that is 4 pi r square dr, with r it will tell the presence of electron at a distance r from the nucleus. This is also a very correct statement. So answer should be B, C and D. It's a completely conceptual question. So B, C, D is the right answer. So I'll go to the question number 11 based on stoichiometry. So you can see each mole of A, substance A, molecular mass given as 720, requires 10 moles of water for complete hydrolysis to give 3 products B plus C plus D in the molar ratio 2:3:2. And if the molecular mass B is given as 40 and it contributes 40% by mass to the total hydrolyzed product, what would be the number of moles of C formed? Go through the question once, try to figure out how to do it. Let us go to solution. What is the equation? 1 mole of A combines with 10 mole of water to give BCD in 2:3:2 2. So it is 2B, 3C and 2D. So 2B plus 3C and 2D. Now A is 720 grams and 10 into 18 is 180 grams. So we know that in law of conservation of mass, total mass of the reactant is equal to total mass of the product. So B is corresponding to 40%. So B equals 40% of total product, that is 720 plus 180, 900 grams. That means it is going to be 360 grams of B. And also atomic mass is given, so number of moles of B is equal to 360 by 40, which is equal to 9 moles. So 9 moles of B is formed, means what would be the number of moles of C which is being formed? If I take ratio of number of moles of B to number of moles of C is 2 is to 3. So number of moles of B is 9, number of moles of C is 2 by 3. So number of moles of C is equal to 27 by 2, which corresponds to 13.5. So if I go back to the question, you can see answer should be B, 13.5. So it is molar ratio, not exactly 2 moles, 3 moles and 2 moles. It's only ratio. So I am taking ratio of moles as 2 by 3 and finding out the number of moles of C formed, 13.5. So answer is B. Next question. An aqueous solution is prepared by dissolving glucose and urea in water. The mole ratio of glucose and water is 1 is to 10 and the mass ratio of glucose and water is 3 is to 1. So what is the mole fraction of glucose in the given solution? So if you look at this, mole ratio of glucose and water. So number of moles of glucose is to number of moles of water equals 1 is to 10. That means mass of C6H12O6 is to mass of water becomes 1 mole is 180 grams and mass of water is also 10 moles means 180 grams. So 1 is to 1. Then implies one more thing is given, mass of glucose C6H12O6 is to mass of urea is given as 3 is to 1. So if mass of glucose is 180 grams, urea mass should be 180 by 3. So I can write mass of urea is equal to 180 by 3, which is equal to 60 grams. So if you take the formula of urea, NH2CONH2, I can say molecular mass is also equal to 60. That means you have 1 mole of urea plus 1 mole of glucose and 10 moles of water in the mixture. So what is the mole fraction of glucose? So mole fraction of glucose is equal to 1 by 12. So total number of moles is 10 plus 1 plus 1 and number of moles of glucose is 1. So 1 by 12 is the mole fraction. So answer should be B. Next question. We have a 200 ml of mixture of CO and CO2. So this is passed through excess of red hot coke, and which is converting carbon dioxide to carbon monoxide. And after passing the gas through the charcoal, the volume increases to 270 ml. So to select the correct statement from the given following options. We'll see the option little later. First we'll see CO plus CO2. So if I take 200 ml, I'll take this as X, this as 200 minus X. So we know only CO2 is participating in reaction. So CO2 plus C gives 2CO. If I take X volume, this will become 2X. Therefore, total volume. So CO2 is not there. After that, everything is CO. So total volume of CO will be 200 minus X plus 2X. That becomes 200 plus X. This is given totally 270. Therefore, I can write X is equal to 70. So volume of CO2 is 70. Volume of CO is 130. This is the basic calculation what we can make out. So I'll go back to options now. So volume percentage of CO in the original mixture is 65. So what is the volume percentage? I got the volumes of two things. Carbon monoxide is 130 and 70. So 130 by 200 into 100. This is the volume percent, which comes to 65% by volume is carbon monoxide. That is option A is correct. If the original mixture is passed through KOH, the volume will be reduced to 70 ml. So in KOH, only carbon dioxide can be absorbed, because carbon monoxide is a neutral oxide, carbon dioxide is an acidic oxide. It can be absorbed by KOH. So volume of carbon dioxide is 70. So out of 200, 70 is going out. It will reduce to 130, but not to 70. So this is wrong. Mole fraction of CO2 in the original mixture is 0.35. So mole ratio is volume ratio. If I take the carbon dioxide is 70 and 70 moles, and carbon monoxide is 130. So mole fraction of CO2 equals 70 by 70 plus 130. So 70 by 200, 7 by 20, which is equal to 0.35. So option C is also correct. And minimum number of moles of red hot coke required is going to be 70 millimoles. So here we cannot find out the actual mass of or number of moles of coke required, because it is given only volume mixture. We don't know the number of moles exactly present. It depends upon pressure and temperature, which is not available. So we cannot consider this option to be correct. So I have to rule out this option as well. So answer should be A and C. This is the method. Once you get this, we can calculate all the options. So it should be A and C. Sorry, I need to tick the answer. A and C is the answer. B and D are wrong. We'll go to next question. The simple acid-base mixture, molarity calculation. The volume of 6 molar sulfuric acid, which should be added to 10 liters of 1 molar sulfuric acid to make it as 20 liter 3 molar sulfuric acid. So just dilution or addition, mixture of two acids. So I can write V1 M1, because all through we have only sulfuric acid. I can use V1 M1 plus V2 N2 is equal to V3 M3. If I have different acids, then I have to use normality. Since all are sulfuric acid, N factor will remain same. I can use molarity. So V1 I don't know, into 6 molar plus other one is 10 liter 1 molar, 10 liter 1 molar, and the second final solution is 20 liter 3 molar. So 20 liter 3 molar. So 20 into C 60, 10 into 1 is 10. So V1 into 6 is equal to 60 minus 10, which is equal to 50. So V1 equals 650 by 6, which becomes 8.33 liters. So option should be C, 8.3 liters. It's a simple possible question for mixing of acids. Now this one, we are mixing different solutions. You have to find the ionic concentration. So carefully observe, 500 ml of 0.1 molar KCl, 200 ml of 0.01 molar sodium nitrite and 500 ml of 0.1 molar silver nitrate are mixed. So please look into that. You have silver nitrate and KCl, Ag plus and Cl minus will precipitate to form silver chloride as a precipitate. So the Ag plus concentration, Cl minus concentration must be less than what is going to be there in the beginning. So we'll see first the number of millimoles. So first one, 500 ml of 0.1 molar KCl. So 500 ml of 0.1 molar KCl means K millimoles of K. K plus is 500.1 is 50 and Cl minus is also 50. The second one, 200 ml 0.01 NaNO3. So 200.01 NaNO3. So Na plus millimole is 200.1 is 2 and NO3 is also 2. The third one, 500.1 molar silver nitrate. So 500.1 molar AgNO3. So Ag plus is 50, NO3 minus is also 50. So Ag plus 50 and Cl minus 50, they will convert into AgCl. So solution will be having almost zero concentration of both chloride and silver ion, and nitrate will be 50 and plus 2, 52 millimoles. So what is the concentration of K plus? K plus is equal to 50 millimoles by total volume 500 plus 500 plus 200, 1200. So 5 by 120 is going to be 0.04 molar. Okay. Same way, Cl minus is almost 0. So Cl minus equals Ag plus is almost equal to 0. Then what is left? In Na plus. Na plus is totally 2 millimoles by 1200. So it's going to be 2 by 120, or sorry, 2 by 1200 or 1 by 600. So it's going to be 0.0016. Same way, NO3. NO3 minus is 52 by 1200. So if you carefully look at the options, so whenever Ag plus is there here, Ag plus is there, so option A is and C are ruled out. K is 0.04, Na is 0.016. This is wrong, so option B should be the right answer. So 52 by 1200 also comes to 0.0433 molar. So option B is the correct combination of ionic concentrations in the given mixture. K plus, Na plus and NO3 minus will still remain in solution, but Ag plus and Cl minus gets precipitated. So answer should be B. Question number 16. A and B are two identical vessels. A contain 15 grams of ethane at 1 atmosphere and 298 Kelvin. The vessel B contains 75 grams of gas X2 at the same temperature and pressure. So what is the vapor density of X2? So we have two identical vessels. One contain 15 grams of ethane. 15 grams of ethane means 15 by 30 moles, which is equal to 0.5 mole. Since the temperature pressure is same in vessel B also, the number of moles of B is also going to be same as A. So 75 grams of B, therefore 75 grams of B container, that will be X2, is going to be 0.5 mole. So 0.5 mole is 75 grams. So molecular mass of X2 is 75 by 0.5 is going to be 150. If molecular mass 150, vapor density is molecular mass by 2, that is again coming to 75. So answer should be 75, that is A is the answer. Okay. So based on the number of moles, because the temperature and pressure being same, number of moles has to be same because the volume of the two containers are absolutely identical. Next question, the vapor density of a mixture of gases A and B is 40. Mixture of gases is 40. The molecular mass of A is 20 gram per mole and the mixture contains gases in the ratio 2:3 by volume. What is the molecular mass of B? So let us say the vapor density is 40. So vapor density is 40. Therefore, molecular mass of mixture will be 80. And we know volume ratio of A and B is 2:3. I can 2:3, right? Yeah, 2:3. And atomic mass of A is 20. So if I take mixture 2 moles and 3 moles, then 5 moles together will be there. So I can write 2 into molecular mass of A plus 3 into molecular mass of B is equal to 5 into molecular mass of the mixture. So 2 into 20 plus 3 MB is equal to 5 into 80, which is equal to 400. If you solve this, MB will come to 120 as the value. So 40 is subtracted from 400, 360 is equal to 3 MB. So MB is equal to 120 gram per mole. So answer should be 120 gram per mole. Answer should be C. Example 18. 1 liter of gaseous mixture, that is containing methane and hydrogen, effuse in 200 seconds, while 1 liter of another gas X takes 10 minutes to effuse through identical condition. If the molar ratio of methane and hydrogen is 1:2, what is the molar mass of the gas X? So here mixture is given, mixture composition is given, we can find out the molecular mass of the mixture. So first we will do that. So what is the ratio? 1:2 for CH4 is to hydrogen is 1:2. That means 1 mole of methane and 2 moles of hydrogen. So what is the average molecular mass of the mixture? So it's going to be molarity of mixture is equal to 1 into 16 plus 2 into 2 divided by 3 moles. So it becomes 20 by 3, it is 6.66. That is the molecular mass of the mixture. So now we know the molecular mass of mixture, we know the effusion rate of mixture and the gas X. I can use the Gram's law of diffusion. What is Gram's law of diffusion? R mixture by Rx is equal to root of molecular mass of X by molecular mass of mixture. So what is rate of diffusion? The volume of the gas diffused per given time. So, volume is 1 liter. So, 1 by 200 seconds for mixture. For X it is 1 by 600 second, 10 minutes. So, it is 600. So, you can see here 10 minutes and 200 seconds. So, if I take that, that is equal to root of molecular mass of, this is for X by molecular mass of mixture is 6.66. So, this will get cancelled. This is 3, 3 goes numerator, 3 is equal to root of mx by 6.66. So, if you have to take out the square root, it becomes 9 is equal to root of mx by 6.66. So, square root is not there. So, if I take mx is equal to 9 into 6.66, it comes to 60. 59.99 it will come. So, it is going to be 60 as the molecular mass. So, answer should be D. So, effusion, diffusion concepts important. You can get questions in any format of the examination. Example 19, for two gases A and B whose molecular masses are given as Ma and Mb. It is observed that at a certain temperature T, the average velocity of A is equal to RMS velocity of B. So, average velocity of A equal to RMS velocity of B at a particular temperature T. The average velocity of A can be made equal to average velocity of B if. So, first we will understand what is the average and RMS velocity. If I take average velocity, C average is root of 8 RT by pi m, and C RMS root of 3 RT by m, and all of us know C RMS is greater than C average. Now, in the first case, what is given? C average of A is equal to C RMS of B, and I want to make now C average of A equal to C average of B. That means the RMS velocity of B is greater compared to average velocity of B. So, if I want to make C average of A equal to C average of B, the velocity of B has to be decreased. So, if velocity of the B has to be decreased, then temperature of B should be lowered and A is at the same temperature T. So, if you see the other options, both A and B are raised in temperature, temperature of both A and B is lowered, both are incorrect. Temperature of A is lowered and T2 B is at T, it will be opposite. So, option is A is the right answer for this particular question. So, temperature of A has to be kept as the same thing and temperature of B has to be slightly lowered so that the velocity becomes equal to average velocity of A. Okay. Now, question number 20. The critical temperature and critical pressure of a gas is 87 degrees Celsius and 80 atmosphere, and the molar mass is given as 130 gram per mole. The compressibility factor Z is less than 1 under the following condition. So, when the Z will be less than 1 for this out of the 4 given condition. So, you do not require all the data. So, molar mass 130 is not required. You need to go with the critical temperature. So, what is critical temperature? We know that Tc is equal to 8A by 27 Rp, and also we know Boyle's temperature as A by Rp. If you substitute that, Tc is equal to 8 by 27 into Tb. So, what is Tb is equal to 27 by 8 into Tc. So, Tc is 87 degree, that means 87 plus 273. It comes to 87 7 plus 3, 10, 1, 14, 15, and 3. Sorry, yeah, 350, 360. Sorry, 360. So 360 Kelvin. Then multiply 27 by 8. So TB is equal to 27 by 8 into TC. So if you substitute, TB is equal to 8 by 27, correct? Sorry, 27 by 8. I'll take eraser, 1 second, pen. So 27 by 8 into 360. This will come to, 1 second, this will come to 1215 Kelvin, which is equal to 942 degree Celsius. So all of us know, if the gas is below Boyle's temperature, the gas behavior will be like this. If the gas is above Boyle's temperature, it will be like hydrogen. So Z will be greater than 1, Z will be less than 1. So if the gas is below TB, definitely Z will be less than 1 in this region. So if we go to the conditions given, so 1200, 1100, 1000 all are more than 942. Option A would be the one with 800 degrees Celsius, which is well below Boyle's temperature. So that is going to be the option where Z is going to be less than 1. Example 21, which the following statement is correct. It's conceptual. So let us see the question. Hydrogen and helium are impossible to liquefy at room temperature. Hydrogen and helium have their Boyle's temperature and even inversion temperature much lower than the room temperature. As a result, at room temperature, straight away they show positive deviation from the ideal behavior. Z is greater than 1, attraction forces will be weaker, repulsive forces are dominating, so we can never liquefy hydrogen and helium at room temperature. So option A is correct statement. For ammonia, Z decreases more rapidly on increasing pressure than methane. If you take methane and ammonia, ammonia has a stronger intermolecular force of attraction. They can be more compressible compared to methane. So even this is also correct. So the Z becomes less than 1. If you go on applying pressure, it can be easily liquefied compared to methane. Then at high pressures, the repulsive forces will dominate over attractive forces. If you see the graph of PV versus P, this is the ideal behavior. PV is equal to RT. This is going to be the normal behavior of the gas. This is the behavior of hydrogen and helium. For both of them, if I go for high pressure region, you can see that there is only positive deviation. So Z is greater than 1 means repulsive forces will dominate. So option C is also correct. A real gas showing the equation PVM minus B is equal to RT. If you take this, PVM is equal to RT plus PB. So if it is going to be RT plus PB, 1 second. So if you divide by PB by RT, so 1 plus PB by RT. So Z is something 1 plus some quantity. So Z is greater than 1. So you cannot liquefy the gas when the equation is obeyed by the real gas, with A being neglected. So A accounts for stronger intermolecular force of attraction, which is enabling the liquefaction. So D is a wrong statement. A, B, C are the correct statements. Example 22, you have some matrix math, simple one. So gas at critical temperature. So gas at critical temperature, definitely it can be liquefied. Then liquefaction is happening means it is deviated from ideal behavior. This is not possible. Attractive force dominate over repulsive forces. It's going to be P or S. Then gas at Boyle's temperature and low pressure. So gas at Boyle's temperature and low pressure means it is ideal behavior. So it is going to be only R, because PQS is for deviation and liquefaction, and Z is less than 1. So compressibility factor Z is less than 1. Again it is going to be Z is less than 1 means I can liquefy. There is a deviation from ideal behavior. Attractive forces will dominate. Again it is PQ and S at high temperature and low pressure. So the real gases deviate maximum at low temperature and high pressure. The opposite condition, they tend to show ideal behavior. So high temperature, low pressure gas follows ideal gas equation. So answer should be A will be PQS, B will be R, C will be again PQS, and D will be R. Question number 23. A vessel of 10-liter capacity has 4 grams of helium gas. The vessel is heated in such a way that the absolute temperature doubles. In order to make the pressure half of its initial value, the mass of helium is to be removed. So, how much of helium has to be removed? So, let us say first I take 10-liter capacity, 4 grams of helium is 1 mole. The vessel uh, pressure I take it as P, temperature as T. So if I take that, so V is 10 liters, which is fixed, and number of moles N1 is 1, because 4 by 4, which is equal to 1, P1 as say P and T1 as T. The second case, volume is also 10 liters, number of moles I have to find out. P is getting reduced to half and temperature is doubled. So P2 is equal to P by 2 and T2 is equal to 2T. So I'll equate this P1 V1 by T1. N1 T1 is equal to P2 V2 N2 T2. V is common. So P by N is 1 is T is equal to P by 2 N2 into 2T. So PP cancel, TT cancels. So what do I get? 1 is equal to 1 by 4 N2. So N2 is equal to 1 by 4 mole. So it's going to be 1 gram. So 1 gram can remain. That means 3 gram has to be removed. So 1 gram out of 4 grams, 1 gram can remain. So 3 grams has to be removed. So number of moles of helium is 1 by 4. So mass of helium is going to be 1 gram. Therefore, mass to be removed is 3 gram. So answer should be C. Okay, this is a solution for the same question. So these are some of the problems what I thought to discuss in this particular session. I hope the session is useful to all of you. Thank you.